I mean, we can make a partition of this population in two types. Say the deer that carry TPC gene, let's write it T, and the deer that do not carry TPC gene, say T complement. Also, another gene they are talking about, let's say that, let us represent this by SD gene, right? Right. So this set here is S. We're writing S for this circle. Okay. Now let's write the information given here in mathematical terms. So they are saying 35% of the animal in a deer herd carry TPC gene. So let us write this PT. TPC gene means probability of the deer selected carrying TPC gene would be 0.35. 35%, 0.35. Okay. Also, PT is known. We can find PT complement. And that is very easy to find. 1 minus PT. And 1 minus PT means we are getting 1 minus 0.35. And that is equal to 0.65. Okay. PT and PT complement is given. Next, they say 58% of these deer also carry ST gene. Which deer they are talking about? The one that carry TPC gene. Okay. So how do we write it? We write it P SD gene means S given that they carry TPC. That's how. P probability of the deer carrying SD genes given that we always write it in denominator, and that is given to be 58%. So let us write it 0.58. Okay. Also, P of the next information, they say 23% of deer without TPC carry SD gene. How do we write that? We write it like this: probability of S over T complement, right? They clearly said here. And this value is given to be 23%, is it? 0.23. Now, what they're asking finally, a deer is randomly chosen and found to carry SD genes. So that means he already known that the deer is carrying SD genes. So to find the probability that it does not carry TPC. So does not carry TPC means T complement, and found that he carry SD genes. So this is what they are asking. Now we will use the Bayes theorem, and Bayes theorem says P of T dash over S. It's very easy to write it. We just make it upside down, PS over T dash. All right, multiplied PT dash. We have learned the proof of this, but here we do not need the proof. We simply applying it. And in the denominator, we will write this and this, means sum of these two. In fact, that is, we say PS, denominator should be PS, and PS can be written in two ways, this and that. So we write it in this way, P of S over T complement time P of T complement, okay, and plus P of S over T and multiply with PT. What do you get? Simply put these values there. S over T complement is given, that is 0.23. 0.23 multiply PT complement is also given. We have calculated here, right? 0.65. No problem. Divided by, we have 0.23 into 0.65 multiply PS over T is given 0.58. 58 multiply PT. This should be written in bracket, right? So PT is given, here it is, 0.35. 0.35. So you can simplify this, and your answer to this will be 0.4241. This is the approximate answer, and if they ask you up to three significant figures, so you just write this in three figure 424. So that is the required probability.